Good morning. Let's discuss these exercises. Page 56. Surf exercises 2.9. Question number 4 in your textbook. So look at this question. Diagram on the right show part of the curve. So this is the curve. Y equal to ax plus b over x. So this straight line is normal to the curve. So normal to the curve. Remember, every time when you see normal to the curve, you need to think about tangent to the curve. So tangent to the curve meaning that gradient tangent is dy over dx. And then when you see normal to the curve, you need to apply this formula. Gradient tangent times gradient normal equal minus 1. Meaning that gradient normal is negative 1 over gradient tangent. So need to substitute dy dx inside. So gradient normal is negative 1 over dy over dx. So this formula you must use later on. So next, the question is at P, this point P, given this point, and this normal intersect the curve at Q again. So how to find the value of A and B? So look at the solution at here. At first, we need to find the gradient for this straight line first. This straight line equation is this. Gradient is dy dx. So rearrange this formula become in terms of y equal mx plus c. So 3y, this x bring to here. So become 3y equal to x plus 14. So to get the y, divide 3 for each term. So divide 3 getting 1 over 3. Divide 3 getting 14 over 3. This one is 1. So divide 3 is 1 over 3. So from here, we know gradient equal to 1 over 3. So this one is, just now they say gradient of normal, right? So gradient of normal to the curve, right? This one normal. So gradient for this straight line is 1 over 3. So this 1 over 3 is gradient normal because this straight line is normal to the curve. So gradient normal is 1 over 3, meaning that just now I say gradient normal, gradient tangent equal negative 1, right? So 1 over 3 over gradient tangent equal to negative 1, meaning that your gradient tangent is negative 1 divide 1 over 3, negative 3. So from here means that dy over dx is negative 3 from here, gradient of tangent. And then look at the curve that you have. So the curve that you have this equation, right? Y equal to ax plus b over x. So this one you need to rearrange before you find dy dx. So a number x power something. So this one become bx power negative 1. So find dy dx because you know dy dx is negative 3 just now, right? So find dy dx now. So differentiate ax, you're getting a. Differentiate this, you're getting b times negative 1. So negative b. So dy dx right here. So differentiate ax, getting a. Differentiate this, b times negative 1. So you have minus b. X copy down, power minus 1. So minus 1 minus 1 minus 2. So this one rearrange again, you have a minus b power minus 2, meaning that at the bottom, so over x power 2 like this. And then you have 1 point, right? So at this point, this is x value, this is y value. So you can find, and then you know also dy dx equals to minus 3. So you can substitute, this one is my a, and then minus b over, so x just now is 1, right? So substitute 1 square equal to minus 3. You combine these two information and then rearrange, you're getting first formula a minus b equals to minus 3. So second formula, how you get it? And then you have the point, right? 1, 1 and 5. So this is x value, this is y value. You can substitute this point because this point is lie on this curve. So you can substitute the value inside the equation to get the second equation. So substitute x equals to 1, y equals to 5 inside the equation, original equation of the curve. Simplify, you get second equation. So what you do is, first equation and second equation, you solve it simultaneously. So from here, using elimination method will be easier. So equation 1 plus equation 2. A plus A, getting 2A. Minus b plus b, so b already gone, minus 3 plus 5, you have 2. So a, 2 divide 2, getting 1. After get a equals to 1, substitute this into equation number 1 or equation number 2. Okay, so up to you. If want to substitute inside equation 1, 1 plus b equal to 5, meaning that b is 4, also can. So this is how we get equation the answer for A and B.